Hello, my name is Peter Levitt, Storage Product Architect for Netgear Ready Data. The following demo will showcase some of Netgear Ready Data's simple-to-use enterprise features, including our easy-to-deploy NAS and SAN capabilities, instant provisioning and instant expansion, which allows you to provision and expand storage in seconds, not hours, with no impact to users. Built-in data deduplication and compression to save vast amounts of storage. Unlimited snapshots and data recovery built into every system for granular protection. And finally, a simple user interface to manage all of these features. Now, let's begin. Here we have a brand new Ready Data system which we are going to configure. To do this, first we must create volumes. So we select the Storage tab, where we can see all the drives installed in the system. We then select the drives we would like to include within the volume. In this case, I'm going to select 12 drives. Once I've selected all these drives, I click Create. I then choose the RAID level. We support RAID levels 0 through to 10. In this case, I'm selecting RAID 6, and I'm giving my volume a name Vol1. I click Create, and then the volume is created. Creating a volume takes about 20 seconds, regardless of the number of drives that you choose. This is called instant provisioning. Once the volume is provisioned, you'll see we have 9 terabytes of capacity. Expanding a volume is just as easy. We just select the drives that we'd like to use for expansion. So once again, I'll select 12 drives, and then we click Expand. The expansion process is just as fast as the creation process. It has no impact to users or applications accessing the storage and is risk-free. We call this instant expansion. In this situation, we're literally doubling the amount of storage this volume has. You'll notice it goes from 9 terabytes to 18 terabytes. And there it is. Now that we have a volume, we can create shares for NAS access and LUNs for iSCSI access. We go to our Shares tab, and from here, we start creating shares and LUNs. First, I'm going to create a share to hold my backup to disk data. On this share, I can enable such features as compression and deduplication. This will greatly reduce consumption on the system when writing backup data to this share, making it ideal with any backup to disk solution. Now I'm going to create a share for my file data. But this time, I'm going to set my constant protection to hourly. Constant protection takes snapshots at selected intervals. In this case, hourly snapshots will be created, allowing me to protect data on an hourly basis. We've created some shares. I'm also going to create some LUNs. LUNs are used in conjunction with iSCSI and are ideal for things such as virtualization and databases. This particular LUN is for VMware. I'm going to disable dedupe and compression as VMware is very performance demanding. I'm going to enable hourly constant protection and select the SAN tab, as this will be a LUN, select thick provisioning and the size of the LUN I wish to create. In this case, 2 terabytes. What you'll notice is, when this LUN is created, the volume reserves 2 terabytes of capacity purely for this LUN alone. This means VMware will never run out of space. Finally, I'm going to create one more LUN for my application data. We're going to use this LUN in this demo to have a look at how our constant protection mechanism works. So I'm going to call this LUN app data, and once again I'm going to disable dedupe and compression, and I'm going to set the protection to hourly. This time I'm going to thin provision the LUN. Thin provisioning consumes storage on demand and offers great flexibility. Now that I've created 2 shares and 2 LUNs, I'm going to go to my Security tab and create some users. In this case, I'll create one user just to access my shares. Alternatively, we could integrate the system with Active Directory, and you could use the users and groups from your Active Directory environment to authenticate when accessing SMB shares. But in this case, I'm just going to create the user Peter. I'll use this account to access my SMB shares. I'll now go back to my Shares tab, where I can apply permissions to my shares. I'm going to select the Files share, go to my Advanced Options, scroll down until I get to the Access, and enable Read-Write Access for all users. Now, from my Windows client, I can connect to the share by entering the UNC path. And there are my shares. I'm going to connect to the file share, and I'm going to actually copy some data I have in another location to the share. I'm now going to create a file as well called important file, which we'll attempt to recover later. For the purposes of this demo, I decided to speed up this process. Rather than waiting for the hourly snapshot to take place, I'm going to manually create a snapshot on the file share by right-clicking on the share and selecting Take Snapshot. What you'll notice is this process is instantaneous. Now I'm going to go back into my file share and delete all my file data. To recover the data, I'm going to need to go back to my Advanced Options on the file share and enable Snapshot Access. Enabling Snapshot Access makes a folder appear within our share. The snapshot folder within our share contains all the previous snapshots. As you can see here, Manual Snap is in the list, and within that is all the file data. This shows how manual or constant protection snapshots can protect your data at whatever frequency you desire. We can also do a similar function on iSCSI data, but for this we're going to need to configure iSCSI. Configuring iSCSI on Ready Data is relatively simple. In this situation, I'm going to get the IQN out of my Windows iSCSI initiator. I open the Windows iSCSI initiator, I go to the Configuration tab, and I can copy the IQN into the Windows clipboard. From here, I then go to my SAN tab on the Ready Data. The SAN tab shows me all the LUNs on the system and where they've been allocated. At the moment, neither of my LUNs are allocated, so I'm going to create a LUN group. I give my LUN group a name. In this case, I'll call it Windows Servers. I'm going to go to the properties of my LUN group, and I'm going to add the IQN that I just copied from the Windows initiator. Now, any LUN I add to this group, my Windows client can see. So I'm going to add the app data LUN to this group. I now go back to my iSCSI initiator and put in the IP address of the Ready Data. At this point, I click Quick Connect, and my iSCSI initiator on Windows is connected to the Ready Data. I can now go into Windows Manager and format my iSCSI LUN as if it was any other disk. We'll notice that Disk Manager wants to initialize a new disk. We click OK, and the disk is initialized. We then need to format this disk. We click New Simple Volume and go through the standard Wizard formatting utility. When we're finished, we'll have a D drive known as App Data. We're going to copy some files onto this D drive or this iSCSI LUN, and we're going to test how we can do the same level of recovery we just saw on our NAS data. So I'm going to open that drive. I'm going to go back to the files that I originally had, and I'm going to copy them onto the iSCSI LUN. I'm also going to fast forward this section of the video for the purposes of the demo. Now that we've copied our file data onto our iSCSI LUN, I'm going to take a snapshot once more. This time the snapshot of our iSCSI LUN will be called Manual Snap 2, and the recovery process will be slightly different. So now I'm going to go back to my D drive and actually format it in its entirety. I'm going to right click on the drive and select Format. Windows is then going to prompt me, and I'm going to click Start. The formatting process takes very little time and destroys all the data on the LUN itself. So at this point, we've deleted all the data. So now we're in the same situation we were previously, but with an iSCSI LUN. So how are we going to recover it? Well, now we take a slightly different approach. We go back to our ready data, but we go to the timeline view. The timeline view shows us all the snapshots on every share and LUN. In this specific circumstance, we're going to go to the app data LUN, and we'll see there's the manual snapshot we just created. Now we have a couple of options here. We can either roll back the snapshot if we're completely confident that that point in time is exactly what we want, or we have a second option to clone the snapshot. Cloning the snapshot creates a complete copy of our LUN from a previous point in time, but it doesn't take up any additional capacity. So I'm going to create a clone called Recover. Once the clone's created, we can then see it within our shares view. Now that I have my Recover clone, I want to present it back to my Windows host so I can try and recover my data. So I refresh my SAN view, and you'll notice my Recover LUN is available. I'll add that LUN into the Windows Servers group, and automatically my Windows client will gain access to it. I'll now go back into Windows Disk Manager. From there, I'll need to refresh the view. What we should notice is Disk 2 will appear, which will be 1 terabyte. It's a copy of my app data LUN from the past. I right click on the LUN and I bring it online. You'll now notice app data appears twice on my system. One of the copies of app data is from the past before I destroyed any of my data, and one is the current copy, which is empty. So regardless of what type of data you have, be it virtual machines or file data, using NAS protocols or iSCSI, constant protection on a ready data can provide you with the on-the-box insurance policy you need to protect your business data. Now that we've looked at the NAS, iSCSI, and protection capabilities of ready data, it's time to take a look at some of the networking configuration. As you can tell, a ready data system can be used for many tasks. For this reason, ready data has a virtual networking capability that allows us to create virtual network adapters bonded to physical adapters. This means we can service many networks by having separate IP addresses and VLAN settings for each virtual network adapter we create. To provide redundancy, we support LACP bonding on our physical adapters. This means our virtual network adapters can connect to the network via 2 Ethernet interfaces. You'll see here I'm going to create a bond with ETH0 and ETH1. Once the bond is created, all the virtual adapters that were connected to the individual network cards are connected automatically to the bond. So now, all my virtual network adapters have a redundant, fast connection to the network. And with 10 gig Ethernet, 2 connections is more than enough for any storage system. This concludes the demo. For more information on Ready Data, visit www.netgear.com/readydata. Thank you.